Good evening, ladies and gentlemen. My name is Dimos Tsougias. This is my colleague Vana Kodu, and we are going to represent our team, Applied. Let's start with the basic idea and the goal of our project, which is to reduce traffic congestion in the big cities by a smarter control of the traffic lights. After analyzing the problem, we have concluded that there are three affected areas. First, we have the individual level, and I think that most of us in this room can relate on how many wasted hours we spend every day waiting in our cars. In fact, latest researches have shown that commuters in Athens spend about 7 days every year stuck in traffic. As a result, we have frustrated drivers, we have greater number of accidents, and of course, late arrivals for our meetings. Now, in a wider level, we have huge costs for fuels wasted in traffic, and of course, resources of transport companies in order to calculate efficient routes and timetables. In short, there are difficulties in optimal planning. And last but not least, of course, we have the environmental impact due to the increased air pollution and the carbon dioxide emissions. Let us recall at this point that our own transports are responsible for the 25% of the total air pollution. But what are the measures taken so far to prevent all this? We use stationary traffic lights that don't consider anything about traffic conditions. In cases of unexpected events and accidents, we have the traffic police. And of course, some other measures are the construction of new roads and improvements of the means of transport, but they are very expensive and time-consuming. So our team believes that all these methods have reached to a limit, and we need to enable smarter technology in order to adapt to the traffic conditions. And how are we going to do that? Our solution provides an integrated control system that works with the Applied software. We gather large amounts of data provided by statistics with our data acquisition network, and we create aggregate models for every hour of the day. After, by a traffic detection system, we will collect some smaller data from the traffic lights in order to create more accurate traffic control scenarios. And in the direction of making the city not only smarter, but also greener, our solution includes solar panel installations that will provide throughout the year enough energy to power the traffic lights via a net metering program. Also, this whole idea has been drafted into a ministerial decree with the help of our team's coordinator, Dr. Eugenia Giannini. And I want to say at this point that it's very important that our system, as it is structured, we don't affect the city at all. At the beginning, we want to install some sensors and the wireless network to gather the necessary data in order to train our models. And only after demonstrating our capability, only then we will install the controllers to take control of the system on demand and in real time. Vana.
Our innovative transfer system offers more than just easing the traffic congestion problem. First of all, it manages to reduce air pollution by reducing the amount of fuel consumed on a single trip. In addition, carbon dioxide emissions are reduced, and there is also a significant impact, a social significant impact, through the passage of emergency vehicles. We allow the passage of emergency vehicles, we make it easier for them, and there is also a positive psychological impact on drivers. In order to quantify those benefits, we conducted a case study in Kηφισίας Avenue. It was estimated that a single trip of about 13 kilometers lasted from 25 minutes in the optimal case up to 80 minutes in difficult traffic conditions. Furthermore, it was estimated that about 400,000 tons of carbon dioxide were produced annually by passing vehicles. By implementing Applied's transport system, there shall be a 15% reduction in driving time, followed by a 10% reduction in fuel consumption, which translates into savings of about 19.5 million euros. A reduction in carbon dioxide emissions shall also be noticeable, resulting into profits of approximately 700,000 euros by trading air pollutants. There will also be an approximately 30,000 euro saving, which is the amount that is currently used to operate traffic lights alongside the avenue. The team behind the entire idea is mainly a team of mechanical engineers from the National Technical University of Athens. Our main associates are the Giannini law firm and its partners, so that to help us solve any legal issues that may occur. And there's the IT department, headed by Dimitris Mazinis, an electrical and computer engineer. Thank you all for your attention. We're looking forward to answering any of your questions in either Greek or English.